Hello everybody and welcome to today's lesson on finding side lengths. Today our objective will be we will be able to use trig ratios to solve for side lengths in right triangles. Let's start by recalling the three trigonometric ratios: sine, cosine, and tangent, and also our mnemonic SOHCAHTOA. SOHCAHTOA. And SOHCAHTOA, what it says is that the sine of an angle D is the ratio of the length of the opposite side over the hypotenuse. The cosine of an angle D is the ratio of the length of the adjacent side over the hypotenuse. And then the tangent is the ratio of the opposite side over the adjacent side. SOHCAHTOA. In order to find side lengths, we have to go through these steps. First, we need to label the sides from one acute angle, from the perspective of one acute angle. And when I mean labeling, then I'm talking about the hypotenuse, the opposite side, and the adjacent side. Labeling the three sides of the triangle from the perspective of one specific angle. Then we write a trig equation using a side we have and a side we need, right? We are looking for sides, so the side we need has to be part of this equation. And then we solve the equation, and there is a specific step each time. If x is on the top of our ratio, we need to multiply. If x is in the bottom, then we need to divide. And of course, very important, your calculator must always be in degree mode before we even start. And as always, looking at a few examples will make things much easier to understand. In example number 1, we're supposed to write two equations that could be used to solve for x in the same triangle. Then we're supposed to solve them and round to the nearest hundredth. Nearest hundredth means 2 decimal places. So the very first thing is we are going to write down our SOHCAHTOA. SOHCAHTOA. We're supposed to find x, and we're given the angle with 78 degrees, so that's the angle that we're going to use to label our sides. Across from our right angle, as always, is our hypotenuse. This is the hypotenuse. Then across from the angle of 78 degrees is the opposite side. Opposite side. And then that leaves us with the side that makes up this angle. That's the adjacent side. Now, what do we have? We have the length of the adjacent side, and we need the length of the hypotenuse. The opposite side we don't have, and we don't care about as much this time. So, looking at SOHCAHTOA, which one of our ratios can we really use? We don't have the opposite side. We can't use the sine or the tangent. Cosine is what we are going to use. Now, let's write our equation. The cosine of 78 degrees is equal to 4, the adjacent side, over x, the hypotenuse, and that is the one we don't have. Now, looking at this, let's realize that the cosine of 78, in other words, the term on the left of the equation, can also be written as a fraction with a denominator of 1, and now we have a proportion that we can just cross multiply. Cross multiplying x times the cosine of 78, we get x times cosine of 78 degrees is equal to 1 times 4, which is 4. And now, since we're trying to solve for x, and we don't even have to know what the cosine of 78 degrees is at this point, but we just divide by that term to cancel it out on the left side. Dividing both sides by this term, cosine of 78 gets canceled out on the left. X is equal to 4 over the cosine of 78 degrees. Now it's time to use our calculator. And before we start doing our calculation, again, we have to make sure that our calculator is in degree mode. So, mode, go down 4, go to the right for degree. It was there already, but it doesn't matter, just for the sake of practicing it. Press enter. Now our calculator is in degree mode, and we can go back and do our word. And we can go back to do our work. So, 4 divided by the cosine of 78 degrees, close parentheses, is equal to, and we get a decimal, and we were supposed to round that to the nearest hundredth. Rounding means it's an approximate answer, and the approximate answer is x is approximately 19.24, and this is a side length, so no degrees. This is the approximate length of our hypotenuse. But remember, the problem it said we were supposed to find two equations. Finding two equations, we can't find another equation using the angle of 78 degrees because we just don't have the opposite side. So let's look at the triangle one more time. And again, always write down our SOHCAHTOA. We're going to use it again, but a different part of it. If we don't have the side, the third side given, then the only thing we can use is the third angle. It is not given to us yet, but we can use our theorems to figure it out, of course, right? Remember, 90 degrees are already taken up by our right angle, and that means we have 90 degrees left for the remaining two angles. And if we have one angle of 78, that means that the third angle has to be 12 degrees. Our third angle up here is 12 degrees, and now we can use that angle to find a different way of finding x. And first of all, we need to label our triangle again. And remember, different angle means we're labeling it differently. Not so much for the hypotenuse. The hypotenuse is always the longest side. But certainly the opposite side is now different. The opposite side is down here, the side with a side length of 4. And the adjacent side to our angle of 12 degrees is this leg up here. What does that mean for the formula we can use? We don't have the adjacent side this time, so we cannot use the cosine as we used it before, nor can we use the tangent. The only ratio we can use is the sine. So let's set up our equation. The sine of 12 degrees is equal to the opposite, which is 4 over x. Now, we have a different angle and a different function. The 4 over x is still the same thing because those were the only side lengths that we had or needed. And again, we are going to solve it as a proportion. Sine of 12 degrees times x is x times the sine of 12 degrees is equal to 4 times 1, or 4. And now divide both sides by the sine of 12 degrees. and it cancels out on the left. X is equal to 4 over the sine of 12 degrees. This last part we're going to do on the calculator again. 4 divided by the sine of 12 degrees, and the answer is 19.2389. Approximated and rounded to the nearest hundredth, that is approximately 19.24. And guess what? These two answers are, of course, the same. It's the same side we're talking about. It's just two different ways we found that side. For the next example, we have to again find the missing side length, and we have to round to the nearest tenth. This time only one decimal place. But as you will see, we will set up the equation a little differently. First of all, SOHCAHTOA, and label our triangle. We have the angle of 68 degrees given. So what is the hypotenuse? The hypotenuse is and always will be the longest side of the triangle. The side opposite from angle 68 is the side labeled with X, and the adjacent side is the side next to it that has a length of 12 units. In other words, we're supposed to look for the opposite, and we have the adjacent. That means we don't have the hypotenuse, and therefore we cannot use the sine or the cosine. We have to use the tangent. Then let's set up our equation. The tangent of 68 degrees is equal to the opposite, in other words x, over the adjacent, which is 12. Now, again, trying to find x, we need to solve for x, and this time we have to multiply both sides by 12. Then that cancels each other out, and 12 times the tangent of 68 degrees is equal to x. And here goes our calculator. 12 times the tangent of 68 degrees. Enter. And the answer is 29.70. Rounding to the nearest tenth. X is approximately 29.7. And again, this is not an angle, this is a side length, so we don't use the degree symbol. Now, looking back at the previous example, remember our x was in the denominator, it was in the bottom of our ratio, therefore we had to divide by the cosine or the sine to solve for x. And in the last example, x was on the top in the numerator of our ratio. Therefore, all we had to do was multiply in order to solve for x. That's what we set up in step 3. Multiply for x on top, divide for x on the bottom. Alright, so much for this, and now go ahead and watch the second part of this tutorial.